Hello, let us look at some questions from the second exam of this quarter. So the first question here it says, in the accompanying diagram of the parallelogram ABCD, AC. So here AC would have been from here all the way over to the other side. That is 3x minus 4. So I'm going to write down 3x minus 4. Now EC, in this case, talking about from here to here. In fact, that green line segment is a half of the yellow one. And we get to realize that that must be equal to x plus 12. Then what is the value of x? Notice that this green line segment has to be the half of the other one. So the equation which we can write up is 3x minus 4 is equal to 2 times x plus 12. See, 2 of those becomes the long one. So then we get 3x minus 4, which is equal to 2x plus 24. So of course we can take away 2x and add 4 to each side. Then x must be equal to 28. So which basically tells us that first one is our answer. How about number 2? In the diagram below of the parallelogram, now you see whenever we have a parallelogram here, you have to realize that sum of two consecutive angles will be equal to 180. So if I call this one as A, call this one as B, then we know that A plus B is equal to 180. Now, DCB is 130, so this angle is 130. And angle 1 is 40. Since I don't know angle 2, let me call that as X. Then as I mentioned earlier, sum of this angle and this angle, they have to add up to 180. So equation that I can write up is 40 plus X plus 130 equals 180. Of course, you can subtract 130 and then 40, then X must be equal to, that's right, 10. 10 degrees. That becomes our answer, choice 1. Number 3, which statement is not always true about the parallelogram? The diagonals bisect each other, that's always true. The opposite sides are congruent, always true. The consecutive angles are congruent. Actually, consecutive angles are supplementary. Therefore, number 3 is not necessarily true. Alright, let's move on to number 4. A quadrilateral whose diagonals bisect each other. Now, diagonals bisect each other, that means a parallelogram. Alright, and then congruent diagonals must be rectangle. Then rectangle parallelogram, choice 2 becomes our answer. Alright, number 5. A parallelogram ABCD has coordinates given as these. What are the coordinates of E, which is intersection of diagonals? That simply means the midpoint. So midpoint of AC, which will be these two values here, 1 comma 5, that means 1 plus 3 divided by 2 comma 5 comma 5 plus negative 1 divided by 2. So then here we get what? 4 plus 2. 4 divided by 2 becomes 2. And then once again 5 minus 1 divided by 2 becomes another 2. So 2 comma 2, which is choice 1, becomes our answer. Number 6. Which region could be used to prove that parallelogram is a rhombus? Diagonals are congruent. That's good. Opposite sides are parallel, but that's true for any parallelogram. Diagonals are perpendicular. Actually, diagonals are congruent. It's coming from the rectangle. So we're going to erase that one. Diagonals are perpendicular. This will be from the rhombus. So choice 3 becomes our answer. Number 7. What is the perimeter of the rhombus? So if I were to draw a rhombus here, and then here we get alright, so let's write down the numbers. Since the whole vertical one is 12, then each one must be 6 and 6. Whole horizontal one is 16, then each one would have been 8 and 8. And then what is the perimeter of the rhombus? So I'm going to call this one as x. Then we can set up the Pythagorean theorem. 6 squared plus 8 squared is equal to x squared. And when you combine them together, we get 100 is equal to x squared. That makes x equals 10. So each side is equal to 10. We have 4 sides of that. So 40 times 10 becomes 40, which is choice 3. All right, let's look at number 8. The coordinate of two vertices of the squares are A and B. Now, if you imagine square, now no matter how square has been positioned, you will see that A, B, C relationship here. Notice A, B, and B, C, they're perpendicular. So that means slope that I'm getting from A, B, you should get the negative reciprocal of that to get the slope of BC, because that's what we're looking for. So here, slope of AB is 4 minus 1 over 4 minus 2. Then it becomes 3 over 2. So therefore, slope that's perpendicular to that, BC must be 2, negative 2, negative 2/3 becomes our slope. All right, let's look at number 9. So when we have an isosceles trapezoid, you see the opposite angle, they have to add up to 180. So here we get 2x plus 3x plus 5 must be equal to 180. Then subtracting 5, so we get 5x must be equal to 175. Dividing each side by 5, then x must be equal to 35. Now, since x equals 35, what is the measure of the angle BAD? BAD, in fact, that's equal to 2x. So 2x must be equal to 70. So 70 degrees becomes our answer. All right, number 10. In rhombus ABCD, the measure of inches, line segment AB and then BC is this way. Now we have to realize that in a rhombus, all sides are congruent, so we have to write down 3x plus 2 must be equal to x plus 12. So subtracting x from each side and subtracting 2 from each side, we get 2x must be equal to 10. And when you divide by 2, x must be equal to 5. Now, 5 is not the length for CD because CD is opposite of AB. So what we end up getting is 3 times 5 plus 2, which is equal to 17. And that's how we realize the line segment length BC at the DC. Number 11. What is the length of EF, which means this one? Notice that this is equal to 10, that makes this one also equal to 10. 24 divided by 2 is equal to 24, because subtracted from 40 becomes 16. And then 16 has to be split into 2 locations, so each one will be 8. 8. Then using the Pythagorean theorem one more time, x squared plus 8 squared must be equal to 10 squared. X squared must be equal to 100 minus 64 is 36, where x must be equal to 6. All right, let's look at the next question. Number 12. Here we have to realize that this is 45-degree angle. So in fact, what I'm trying to do is, what if I were to bringing that line segment into over here, then you will see that the this will be right angle, and that's equal to 45 as well. So then this blue line segment must be equal to 6 feet, so this becomes 6 feet. And this also becomes 6 feet. Now, then how do you find the hypotenuse? You can use the Pythagorean theorem, or you can say 6, 6, 6 radical 2. By that ratio, we were able to figure that out as well. All right, let's look at number 13. The quadrilateral KATE has a vertices of that. So let's try to plot the points first. All right, so T is 1, 5. And then 4, 7. That's A. And then T is 7, 3. And then E is 1, negative 1. So what we're going to do is we're going to connect them with the line segment. All right, so then we have a couple plans here that which we have to do. First, we have to show that it's a trapezoid. That means here I'm going to show that slope M KA is equal to slope of TE. So slope of KA, which is 7 minus 5 over 4 minus 1, which becomes 2 over 3. How about slope of TE is 3 minus negative 1, and then 7 minus 7 minus 1, which becomes 4 over 6. Which is equal to 2/3. Since two sides have equal in length, equal in slope, so we realize that KATE must be a parallelogram. A trapezoid. Now, but we also need to show that it's not isosceles. So then I guess we're going to be looking at AT and then KE. Distance of AT must be 4 minus 7 squared plus 7 minus 3 square root of here we get 16. Nope, not 16. 9 plus 16, which we get square root of 25, which is also equal to 5. So that's AT. Now, but TE, in fact, it's a vertical line. KE, a vertical line. So KE, all you have to do is count box 1, 2, 3, 4, 5, 6. That's how you can show that. So all we have to do is write up the statement here. KATE is a trapezoid because KAT are parallel. All right, now, but but it is not isosceles trapezoid because AT is not equal to KE. All right. So that's basically what we can do. Let's go for the last question, number 14. Quadrilateral MATH has a coordinate, so we need to prove that it's a rhombus, but it's not a square. So what are we going to do? We're going to first draw the line segment. M is 1, 1. A is negative 2, 5. T is 3, 5. Six, 1. So if I have to draw the line segment, all right. So we have drawn the rhombus. In order for it to show that it's a rhombus, one thing that which we can do is a distance formula. So let's go for the distances. AM. AM distance becomes 1 minus negative 2. And then second one is 1 minus 5. And then this becomes 9 plus 16, which is equal to square root of 25, which is equal to 5. So MA is equal to 5. Now, how about M? Now we're gonna be looking at AT. AT is horizontal line segment, so we can count the boxes 1, 2, 3, 4, 5. So we get 5 as well. How about this is H, so we get TH. So TH here we're gonna use the distance formula here once again. 6 minus 3 square plus 1 minus 5 square. Then we end up getting 9 plus 16, which is equal to square root of 25, which is equal to 5. And then MH is also equal to 5 because you can count the boxes. Since all sides are congruent, so it is a rhombus. But we are not sure that it's not a square. That means we have to we can just do the diagonal distance of the diagonal, or we can try to see the slope here. Slope for MH is equal to 0 because it's a horizontal slope. But what is the slope of AM? Slope of AM here, so that means I have to go for 4 minus 1, or 5 minus 1, over negative 2 minus 1. So it becomes 4 over negative 3. Now, when you look at these two slopes, they're not negative reciprocal to each other, so Therefore, we don't have a right angle over here. That tells us that math is not a square because angle M is not 90. So it's not a right angle. That's why it's not a square. All right, so I think we're gonna stop here, and I'll see you later. Have a great day.